right. All right. So maybe Japhy gave us this interesting problem.
You can use a binder clip to launch another binder clip.
I think I'm just going to disable the music.
So then you wonder, how can I maximize the distance this thing travels? Of course, if the projectile hits the ceiling, it's better to be lower so that you can aim upwards, giving the projectile more airtime. So pass the calculus and the algebra as I did in my other video.
That is a lot of calculus.
So rather than spending the rest of this, easily compute the capital H initial height, capital S for the launch speed, and the angle. Well, we need the launcher to give the projectile just enough energy to reach the ceiling, which energies at any point in the flight will be very close to constant. So we can the gravity of Earth times height. Since air resistance is not a significant factor, the sum of these two energies at any point in the flight will be very close to constant. So we can equate the total energy at the starting point, where the speed is s and the height is h0, with the total energy at the point where it reaches its maximum height, where the speed is s cosine theta naught, and the height we can say is capital H because that's what we need it to be. Okay, so the next step would be to derive an equation for the distance the projectile
There we go. Chat is always on. All right. So I don't know if I can even solve this, but we can try. We can always try. We can always try. You know?
That's what we need it to be. Okay, so the next step would be to derive an equation for the distance the projectile will travel, and then find the maximum of that function.
Oh shoot, I just got some Discord server I moderate for has some roles problems. And manage permissions. Oh, God's sake, why? Got it. Oh. I don't care about that too. Oh, God.
Here's the general equation for a projectile's height as a function of time,
Mm-hmm.
and one for the distance traveled as a function of time.
Mm-hmm.
I think that's enough to get you going.
So we need to find the ideal projectile. Oh, God. So let's just graph it. So let's just have like y equal to 0, right? Then let's say
This either, as I did in algebra, will reach by raising the compute the constraint that ties the height the projectile can reach without touching
height. So let's just write h. H is gonna equal 5. Now, all right.
the ceiling. I'm using 3 meters for this animation.
Okay, so let's use 3 meters. Of course, we're using metric system because metric system is the best.
Let's use h naught for the initial height.
H naught for the initial height. Let's make it 1. So, you know what? We're just going to do 1 quadrant. Haha. Let's make this like time thick. Do I even need this anymore? Nope. Alright, so then... Okay. So if we take h naught, which we're just going to graph the point 0, h 0 for reference. So now I can move it up and down.
Capital S for the launch speed, and theta naught for the launch angle.
So S is, let's add a note for now. S is angle. Okay, wait, so let's just draw out the vector. Oh, hi, King the Delicious. Yeah, you know, it'll be fine. Probably not. I love copyright. Well, actually, technically, I'm not breaching copyright because I'm giving commentary on the video. So technically, I'm giving thoughtful commentary on this. I have to be more consistent with it. But technically, I'm not breaching copyright. Obviously, YouTube might still, you know, be YouTube. I just have to keep talking. So he says we're gonna take that. So I need a graph magnitude. Okay, so if we, you guys got to see how bad I'm at math. So can I just have s times the sine theta? Wait, how if I just did this? Oh wait, shoot, they're mixed up. Cosine s times sine theta. We need to add s. Oh, and then we need to add this to h naught plus too many variables. I don't know what to do with this. Oh, well, we need to find theta. Theta is equal to 30. What do you mean too many variables? They're all defined. I just love it when Desmos is being stupid. What if I do that? There we go. I wasn't being stupid. Okay, I think it's because I'm in radians. Yep. I know, you degrees. I know. Okay, so we got our angle, right? Okay, how about we just draw a little polygon between those 2 points? Two. And just copy that. Here we go. We got a vector. Amazing. All right. What else?
How might we go about finding a formula to relate the height and the angle?
Because...
Well, we need the launcher to give the projectile just enough energy to reach the ceiling.
You know what? I can
which
just mute
suggests
the video. Okay. So that's kinetic. Oh, I don't know if even taking a physics class will allow me to figure this out. So it says 1 is equal to m. So what is m? Mass. Okay, so m. Oh, okay. M is mass. Let's put it at 1 kilogram or whatever it is. One. Okay, so this is 1 half. What is velocity? Oh, well, that gives us a vector. No, what I can do is turn on subtitles. Okay. Okay, so kinetic potential. Wait, if we add that up, then, you know, energy. So 1 half v. 1 half m v. Wait a second. V squared. That's literally, you don't need the absolute value because that is going to be positive. G is going to be 9.8. And G, what even is H here? Which H? Oh. It should be that H because when it's at 0, there's no kinetic energy and it has all of its potential energy. So it should be GH. No. Equals. And then. And okay, so we're ignoring air resistance. Okay. Okay, so we're just taking the magnitude. Makes sense. So I can replace that with S. Get a value. Epic. Oh. Oh God. Why? Okay, so then we can say. Okay, so also this does change because that's the velocity. So then you're saying if we take this is getting messy, but it's okay. Plus 2 is going to be equal to... Okay, so 1/2 m. As cosine theta naught. Okay, so it's at the peak. Do I even need that? Why do I even need that? Okay, so I guess we can, like, solve more stuff. Oh, okay, so we want to take the max? Okay. I'm just gonna write that separately. Wait, theta naught should always... Oh, that's theta... Okay, theta naught is theta var, so... One half m times s cosine... Oh, shit. Doop. Cosine theta squared. That's one annoying thing I've realized is if you switch tabs and then come back in, it always puts your cursor at the end. Kind of weird. How many people are watching? One. Let's see. Do-do-do-do. All right. Do-do-do-do. Okay, wait, so cosine squared plus mg h. Okay, what is wrong? Cosine. No, I needed something inside the cosine. Duh. Beta mgh. Right, so these two should so this is the energy at max and this is energy at initial, and they should be equal to each other. Wait a second. Now what is error? So we know that angle is variable and that, well, that one isn't, but the initial height is variable also. Just put that 0 to h. There you go. Okay, oh, and then we want to make that a function of velocity. Okay, so yeah, we want to make this a function of s, which is the velocity. So, okay, we can do this. This isn't as bad as it would. Actually, it's still pretty bad. Alright, so we set these two equations equal to each other. This is where I would usually just put it on a piece of paper, but we're doing it on stream, so can't do that. Oh, it doesn't give you any error anymore. That's pretty nice. Okay, so now we just gotta height. Okay, that's that's pretty useful. -1. Actually, I recognize some of these things from my physics class. This is a pretty cool problem. GT squared. Maybe I'll bring this to like my physics professor or something. Well, probably not though. GT squared. So plus sine. Not quite. That is sine. That's sine theta. As a, I don't know if you're still. Oh no, never mind. You're no longer here. I was gonna say, King Delicious. I don't know if you've solved it yet. Sine. No, he has not responded. Sine theta t plus h. Okay, so it doesn't know what t and doesn't know what h is. Oh, that's h is not. Okay, and it's a function of t, so all I gotta do is t is equal to. Oh, sorry, theta. There we go. That looks a little bit wrong, but yeah, our vector seems to I'll say that looks pretty good. It's just oh, x. Why does no work? Hello. This makes no sense. Why gonna x? If I paste that in, that works. Why doesn't this work? Oh, dear. Okay, so clearly we want that to be exactly. Where is it? Exactly h. You want that top to be h. Okay, that's distance traveled. Is f, right? And f of distance of t. Oh shit. Of t is equal to as cosine theta t. So it's just this part. Okay. I don't quite understand why. Also, I feel like maybe for this, just for this. So I think I could just like could probably just, you know, do this instead. Yeah. I don't quite. This doesn't seem quite right, you know. Okay, but we said that magnitude is always predefined. Or, sorry, velocity I meant. What we can change is the angle. This goes from 0 to 90. Wait. Wait a second. Something is wrong here. That vector point is wrong. Is there 1/2 in front? No. Theta is wrong. Wait, no, this is wrong. This, I think, is wrong. Let's see if t is equal to 0. That's 0. That's h. Okay, wait, that's normal. But why is... Matthew Japhy. Why? Why did you make me do this? I feel very dumb. I don't wanna cheat and look at his graph. Oh. Let's see. H0 or theta, yeah. Find a value. Oh, but clip actually should. I don't know if I want to look at it. That doesn't look nice. Oh god. What have I gotten into? Oh. Let's see, can I just... Okay, so we need to... Oh, wait, that point. Wait, no, that should be right. This thing should... Wait a second. I'm increasing magnitude. It shouldn't be increasing the launch angle. So, S is wrong here. This thing is wrong. There's a missing cosine somewhere. Wait a second. What? Okay. Shoot, I'm just gonna look at the graphing count. The graph. Oh, it's entitled. Oh, okay. He doesn't give a graphing count. Okay. Something is... Why? Okay, so that is... for God's sake. Okay, so we know that the max height is not a variable. That's what we have to solve against. We know that shoot, what is it? I don't. Oh. Oh. I can't figure it out. Do I just give up? No. No, we are not giving up. Actually, it's Matthew Japhy is probably asleep right now. Rip. Alright, I'm back. And this is pain. Okay. I am going to ignore what Matthew Jaffe has said, and I'm going to open up my physics notes and look through those. Let's create a new graph. Oh god. Physics notes have been opened. Oh, rather acquired. Oh wait. Wait, no, yeah, that's not macro. It's alright. Newton's laws notes earlier than that. I just want kinetic motions and shooting. Actually, why don't I go grab my formula sheet? Oh wait, here's my formula sheet. I don't need physics notes. I got my formula sheet, which I made for my tests in class. Anyway, okay, so let's recreate some of this. So if I have h equal to 1, or I want to use different feeling. Since we are in Desmos, we have the luxury of being able to name long names for variables. And I'm just gonna, there we go. And then initial height. Height. And let's capitalize the I. Let's be civil. Be good graphers. Level 1, and this is between 0 and now we clearly know what everything is. We know the variables because they're described by their own names. How many people are watching? Oh, it's still cool. Hi, whoever random person out there is watching. We suffer. Anyway, okay, so then we can create the point. Yeah. Alright, let's create the line. Why? Oh, put It's no longer called ceiling. I cannot spell ceiling. Let's make that black and 10. Here, I'm just going to create a folder called graphics. And just throw that in there. We're going to also create this point, which we're going to call initial point, which is going to have 0 and then initial height. All right. Oh wait, is equal to that initial height. Or okay. Oh wait. Huh. Okay. So then. Oh, oops. This is gonna remain at 0. We can. There we go. Do. All right. So then we need. Okay. So then we need to start calculating the parabola. Now, we know that our maximum height has to be at the ceiling, right? So I think I know how to do it. Possibly. Maybe. Okay, so we need to take. You know how. Alright, I know how to do this. So take theta. Let's call this theta high. Theta 1 is equal to, let's say, 30. Are we in degree mode? Okay, I know degrees are cursed, but you know, I'm just used to them. And it's sad. You should use radians. Anyway, then we can take. Oh, what is it? So, yes. Okay. So then we take mag 2 is equal to, let's say, 5 meters per second or something like that. 0 and 14. And we can take the x component, which is going to be y. Wait. Y is equal to show right. But only from 0 x to the cosine of theta 1 times the magnitude. Alright, now we can just control Q. X is equal to 0. And replace it with y, and we're going to replace that with sine. Oh. And we're going to do minus initial height. There we go. Let's just dump that into graphics. So let's call this y vector, and then we have x initial vector. All right, so we have our two vectors here, right? Which we can also take. We can take this point if we wanted to. So this would be how many people? People are still watching. Wow, I was not expecting that. Thank you to whoever's out there watching me suffer. All right, so did I lose my train of thought? Maybe. Possibly. Where was I? Okay, so now I can find the thing. Yes. Go. We can control the magnitude. Epic. Yeah, okay, so now that we have our magnitude, so we now have a vector, right? Let's call this vector and yeah, and the equal sign. Let's just draw a polygon between the initial and vector n. Bada bing, bada boop. We now have our vector. Now we have to figure out the parabola, right? Oh, you know what? We should figure out the parabola first, and then maybe figure the thing, the height. Wait. Oh God, I hate this. I might have to redo stuff. This problem, I know I can do it. It's just gonna take a while. Okay, where's my formula sheet? Okay, here's the formula sheet. Delta x is displacement. That's the final, that's initial velocity. I want something with delta x. That has acceleration. That has time. We don't want time. Because we don't care about that yet. So we know that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times delta x. So now that we've separated into two components, I know exactly what to do. I think, possibly. Alright, so... Okay, yeah, so since we know, we have to define the curve. Once we define the curve, we can figure out, like, the thing, right? We can figure out the theta 1, and we can figure out the magnitude based on where we have that curve. So let's just, like, make a dummy parabola. x squared ceiling. Can't spell ceiling. Okay, and then we have touch. Let's call this minus max. And let's create the point max height. Let's go. Right. And ceiling. I cannot spell ceiling for the life of me. Okay, but we don't really want to move the ceiling. We're just gonna make it only drag sideways, right? So then, aha! We gotta force this point right here. Okay. But we cannot change the velocity. Now, velocity is, let's call this f of x. Let's call this trajectory. That's a trajectory. If you take that, you take the prime of that. So we have that. This has to remain the same. Right, if I move that changes, right? So this has to remain the same. So if we take the derivative of this is just going to be equal to minus that 2 times x. Now, question is, why is those two in different places? Right? Because I don't know math, apparently. It's going to be x squared. We'll put the minus. If we take the derivative, that's going to be x squared. So no, let's just square it. Minus 2x plus m squared, which we know is a constant. So then this becomes minus, and then we just have 2m, and that just, the rest goes away. Okay, so then we just have to do minus 2, except I think they're backwards. Yeah, they are. Oh, because that is negative. So we have a double negative. Yay! Okay, so now that we've figured out this is the derivative of this, right? Which is also this thing. So now we want to keep it the same. We want to keep this value right here constant. Because remember, we cannot change the velocity. We're trying to find the ideal launch angle for and height for a given specific velocity. So, what do we do? Are people still? Oh my god, there's 2 people watching me. Okay, so what do we do? We need to change the slope. We need to change whatever's in front here. Oh god. So how do I do that? Hi, mini mom 4098. Welcome. God, I hate. I mean, I find this problem is interesting, but it's causing me more pain than I would like. Just shows how I need to improve on this. If only Japhy was here. He would be laughing hysterically, probably, or something. Or be very disappointed in me. Either or. For reference, if you haven't checked the description, we're trying to solve this problem that our friend here, Japhy, gave us. Okay, so I said I wanted to keep this right here in 7.4 constant. So basically we have our trajectory here, right? We want to keep this point over here. But we also want to make sure that our velocity is always constant no matter what. So that means we have to change the angle and magnitude, and height, initial height. Now that's 2 variables, so I'm gonna allow height to be controlled. Wait, yeah, but then that's gotta change something else. Okay, no, so they just gotta be a function of each other, and then we just find the max. Why is this so complicated? Maybe I should just give up and try and figure it out tomorrow, right? I have better stuff to do anyway. You know what? This has been a very fun, very short stream. Let's see, how long has... Oh my god, it's been going on for an hour. Okay, that's not quite very short. But if I've barely done any progress at all within 1 hour, there's no way I can get it done tonight, but I have other things I need to do desperately. So, I'm gonna wait, and I'll figure this out tomorrow, or Thursday, or Friday. Can't really do it Wednesday. I'll figure it out another day. Anyway, ladies and gentlemen, have a wonderful night. I'll see you then. Awesome problem though. Bye. Oh, and thanks for coming.